question B and C. So an arithmetic sequence V1, V2, V3, such that V3 is U3, V11 is U5. So this looks quite complicated, but basically we're going to build this second sequence, V's, based on the U's. So we need to go back to the U's. I've drawn across the information that we have from the U's. So if U2 equals 6 and R equals 2, we can easily see that U of 1 equals to 3, right? So there we go. We've got U1 equals 3. So now what we're going to do is we're going to find U3 and we're going to find U5 because we need those for the next part. Okay, so U3 should be quite easy to do. That's just 12. We can even just write that down because it's doubling. And then U5, you can do the formula, or you can just, by common sense, U5 is just double and double again, 24, 48. So now let's see what this arithmetic sequence, so V1 equals V2 equals V3 equals, well, V3 equals U3. U3 is 12. So V3 here equals 12. And then it goes down. Then we eventually got V of 11, and that's equal to U5. Now U5 is 48, so we have 48 here. Now can you see that actually here we could do it in two different ways. We could do simultaneous equations, or we could do it with common sense. So let's do it with common sense first. So from 3 up to 11, there are 8 jumps. So that will be plus 8d. And that would be 12 plus 8d equals to 48. So you would quickly see 8d equals to 36. So d was equal to 4.5. Okay, now if you can't quite see that, then let's write down the formula. Now the formula is like this, but don't forget the u's up here are for geometric, and the u here is just the formula for arithmetic from the formula book. So don't get too confused with that. Okay, so let's deal with the 11th term first. So we have 48 equals to the first term, which we don't know, plus 10d, 11 minus 1. And now let's deal with the second information we have. That'll be 12 equals to v1 plus 3 minus 1 is 2d. Can you see this equation here now? So you've got equation 2 and 1. If I do equation 2 minus equation 1 here, I will get, oh, yeah, it's the wrong way around, isn't it? It's better if I do 1 minus 2, right? 48 minus 12 is 36. v1 minus v1 cancels out, and we've got 8d. You can see that we get to the same result. So either of those ways is absolutely fine. So d equals 4.5. And as soon as you've got 4.5, you can get back to v of 1. You can go back to v of 1 from here, or you can go back to v of 1 from here. So I'll do it on the left hand side. So I've got 12 minus 4.5 minus 4.5 equals to 3. So the first term v of 1 equals 3. Alright, we've got part C to do now. Find the lowest value of n such that u of n is greater than 100 v of n. So I suppose we need to have the both the rules written down. So let's just go and find those rules. So from the previous question, r is 2 for the u, and u of 1 was 3. So let's just get that down on the u page. So here's sequence u, and here's sequence v. D was equal to 4.5. V of 1 was equal to 3. And over here, R was equal to 2. And U of 1, I've forgotten what that one was. U of 1 was equal to 3. Okay, and the question says U of n greater than 100 V of n. So we need U of n greater than 100 V of n. Okay, so let's just go for the formula. Remember, this is geometric, So u of n equals u1 r to the n minus 1, and this is arithmetic. And again, I'm going to use the same u of n formula from the formula book, u1 plus n minus 1 d. So over here, let's take this formula and substitute the r is 2 and the u of 1 is 3 in. So we've got u1, 3, times by r to the n minus 1. We need a value of n such that that's greater than 100, times by the v of n formula. Let's have a look at the v of n formula again. Arithmetic. So it's u1, put in a bracket, plus n minus 1 times by 4.5. Alright, now the difficult thing with this is you've got an exponential and a polynomial. So on the right hand side this is linear, left hand side this is exponential. Now you might need to do logarithms with this, but if this is a calculator paper, we can actually go ahead and use technology to our benefit. You can tidy up with algebra, but I'm just going to go straight for it. So document, insert a graph, and I'm going to just type in the left hand side, 3 times 2 to the exponent, just move that along a bit, exponent, and all in the exponent x minus 1, press enter, and then control G, this is F4, so I've got F3 and F4 here that I'm interested in. This is 100 times by open bracket, 3 plus open bracket again, x minus 1 close bracket, and then times by the 4.5, and we are done. Fantastic. Alright, so we want to know, the exponential is the line in black, and can you see it's below the pink line for what we can see on the view here. But if we do Control T, we're interested in the table of values, right? And we are comparing F3 with F4, okay? F3 with F4. Now you can actually make the column widths a little bit bigger. Okay, my laptop's just a little bit slow on this, so what we'll do is we'll just go down to the 10th term. The 10th term, the exponential is at 1536, and the arithmetic is at 4000. Okay, so we need to go a little bit further. On the 12th term, when n is 12, the exponential was 6100, 5200. So we're nearly there, aren't we? We can see that it looks like moving from 11 to 12 is the key. So we can use the calculator to our benefit there. If I just make this a little bit bigger, if I just make this window a little bit bigger, you see there? We can actually see them side by side now, and that will be a little bit more effective in seeing things. So we wanted to know when is the black greater than the pink. You can see that actually we need to get to the 12th term before that happens. So I have this on your screen now. I'm just going to make this window a bit smaller so you can see what's going on. We go back to our page here, and then all we have to write down is when n equals 11, we've got 3072, and we've got 4800. And when n equals 12, we've got 6144, and we've got 5250. So this one we tick, this one we cross, and because you've structured it out exactly like this, this is a perfectly, fully acceptable answer. You've used technology, maybe from GDC we could put here, and we've indicated exactly how to find that solution. For those of you interested in the actual algebraic solution and what that might look like if it's possible, let's just take this. Let's just insert another page here. And then let's just see where we can get with this. So I'll leave the left hand side where it is. Now the right hand side is going to be 100 in brackets 3 plus 4.5n minus 4.5. 3 times 2 to the n minus 1 is greater than 450n, and that will be minus 150. So 3 times 2 to the n minus 1 minus 450n plus 150 is greater than 0. But here we have a problem, right? Because this is 3. Let's divide everything by 3 actually. 2 to the n minus 1 minus 150n plus 50 is greater than 0. Now the problem is here that no amount of taking logarithms is going to help us unpack this, right? Because you've got n as an exponent here, but then you've got n as a linear term here. You might think, well, hold on a second, this is 2 to the n times by 2 to the negative 1, and that 2 to the negative 1 is just this. So we can go a bit further. We times everything by 2. Now we've got 2 to the n minus 300n plus 100 is greater than 0. But we get to the same end process. If you take logarithms, you can't unpack the logarithm. And you see that the 300n is attached by a subtraction here. So if I try to log this left-hand side, I can't actually unpack. I usually take a logarithm to bring down an exponent from here to here, but it's not going to work. So actually this is a question that you need to try and recognize. If you've got an exponential, needs some kind of linear term, then it may not be able to be solved using our regular algebra. If it's a GDC paper, then I would reach for GDC all the time.